Welcome. In this e-learning module, I shall demonstrate and make you understand how to design the lifting hook for the press tool in Catia V5. In the previous e-learning module, we had discussed how to analyze the bill of material and display the mass value of each part and assembly in the bill of material. Click on Analyze, Bill of Material. Observe the mass values of each item of the press tool. The die assembly weighs 51.226 kilograms. The punch assembly weighs 46.759 kilograms. The press tool assembly technician won't lift the die assembly or the punch assembly due to their enormous weight. We need to make some provision in the die assembly and the punch assembly so that the assembly technician can lift them with the overhead crane or a jib crane. We will incorporate a lifting hook in both the die assembly and the punch assembly. We need to make some provision for lifting parts or assemblies more than 10 kilograms. Let's check for parts weighing more than 10 kilograms. The die plate is 9.704 kilograms. There is also a threaded hole on the die plate. The assembly technician can use an eye bolt to lift the die plate. The die shoe is 33.776 kilograms. There is also a threaded hole on the die shoe. The assembly technician can use an eye bolt to lift the die shoe. The top plate is 33.69 kilograms. There is also a threaded hole on the top plate. The assembly technician can use an eye bolt to lift the top plate. To summarize, we need to design lifting hooks to lift the die assembly and the punch assembly. Like the shoulder bolt, the spring, the screws, and dowels, even the lifting hook is a standard part. As you are already aware, standard parts are what we don't manufacture in our company. We buy lifting hooks from standard part manufacturers. Also note, we don't create drawings for standard parts. I have created this simple drawing to help you design the 3D design of the lifting hook. We refer to the standard part catalogs or brochures provided by standard part manufacturers. These catalogs or brochures are generally available on standard part manufacturers' websites. I recommend you search on the internet and finding some technical information about lifting hooks. Now let's get started with the 3D design of this lifting hook. This lifting hook has the capacity of lifting of 160 kilograms. Create a new part file with the part name as lifting hook. Create a position sketch on the top XY plane. Sketch a rectangle. Apply the symmetry constraint between the rectangle's left and right edges with reference to the vertical axis. Update the length dimension to 32 mm and width to 28 mm. Create a pad of thickness 18 mm. Let's sketch the circular portion of the lifting hook. Create a sketch on the right ZX plane. Sketch the profile of the circular portion. Update all the dimensions as per the drawing. Create a 360-degree shaft. Let's sketch the screw holes positioning sketch. Create a position sketch on the top surface of the lifting hook. Sketch 2 points. Create necessary dimensions. Update all the dimensions as per the drawing. Select the point in the top surface of the lifting hook. Create an up to last hole of dia 7 mm. Apply a user pattern to both the points. Provide a chamfer of 2 mm by 45 degrees to 4 edges of the lifting hook. Provide a fillet of 2 mm to 4 edges of the lifting hook. Set the view to isometric and fit all in. Apply steel material to the lifting hook. Calculate the mass properties using the measure inertia command. Make sure to keep measure as selected. Right-click on the lifting hook and pick Properties. Enter the part number and the part name as lifting hook dia 10, 160 kg. Create a new mass parameter. Create a formula to make the new mass parameter equal to the mass parameter created by the measure inertia command. Set the view to isometric and fit all in. Save the lifting hook. With this, we have successfully learned how to design the lifting hook for the press tool in Catia V5. That's all in this e-learning module. Thanks.